Hello everybody, my name is Borisha and this series of videos will be about the chips which are used in automotive industry, maybe some AMD, some NVIDIA chips, maybe in XP, and in this video especially I will talk about first just in series, but not at least. We will discuss more about other manufacturers. Uh, and this video will be made on English for my brothers Reggie, Wolfgang, and Sorin, and great greetings to them. So this chip is some kind of counterpart of the Orin chip from AMD, maybe better with some characteristics. Orin chip is made by the NVIDIA, but this Versal is made by the AMD, probably in some collaboration with the Xilinx, but we will see about that in the further talks. Uh, the documentation for this chip is very large, so we will going one by one and dig out the most interesting information. So AMD Versal is adaptive system on chip architecture. You know that system on chip architecture is actually combining some different characteristics or different parts which are belonging, for example, one computer, but they are integrated on one chip, like CPU section, GPU section, for example, IE engine section, and so on. In that sense, we are talking about AMD Versal Adaptive System on Chip, which is combined. So that chip system on chip is combining programmable logic part, processing systems part, and IE engines part, and we will discuss about them one by one. Um, IE engine IE engines with these are IE engines are given with the leading edge memory and interfacing technologies to deliver powerful heterogeneous acceleration for any application. In sense, uh, mm, probably it's reduced in size, but let's say in capacity like classical GPUs, but still incorporates also a lot of good features and probably some different features inside IE engine is applied for good work. So IE engines are SIMD. We talked about SIMD but on Serbian, but this is single instruction multiple data. This VLI-W is probably very large integration. So IE engines are vector processors for adaptive inference and advanced signal processing compute. Um, when we say that inference is make like conclusion on something, and advanced signal processing compute, probably some signal processing which is coming on that chip from different sides. Programmable logic. Programmable logic combines configurable logic blocks, memory, and digital signal processor engines, architected for high compute density. Programmable logic, it's in sense of FPGA. So probably there is inside the system on chip, there is some part which task is similar to the FPGA, and that means that that part is programmable in sense of logic, and we combine different components to have our own logic incorporated in our way and in way which we want to this operated. PS or the processing systems, they are like classical processing cores, so nothing new about it. The PS includes simple application in real-time processor. That's the one section. Also given in ARM architecture for ARM for intensive compute tasks. It's a classical. We can say that it's classical processing system. Only like all others, it's in ARM architecture, not classical CPU, which are used in home computers like laptops and so on. And in almost all automotive and robotics, it's ARM architecture, which means it's a RISC architecture, reduced instruction set. Also, these AMD Versal system on chips devices are integrating in one system all three phases of compute in embedded AE applications. It means processing, AI inference, and post-processing. Also, AMD Versal is satisfying automotive 26262 standard. So for some listeners, maybe it's very important feature to be applied in many senses. Let's go to the other slide. What we have here, let's say, a short introduction to the processing system. This second chapter. System on chip includes following features, and these are the parts of the processing systems, and that's the APU section, which means application processor unit subsystem in processing system. Processing system, we look at it as a whole, and this APU is part of that, let's say, a huge block of processing system which we described in previous chapter. And in there, inside the processing system, there is up to 8 ARM cores, which are type Cortex A78AE, organized in clusters with 2 cores per cluster. So one cluster have 2 of these cores. So one APU is actually probably that one clusters, and in total there is 8 ARM cores inside. And there's 8 ARM cores in total in a whole processing system PS, which is described in previous chapter. A system watchdog timer also for each APU cluster. So for every of those 4 clusters, there is a watchdog timer, which is very important, especially in automotive industry, which watchdog timer is watching and monitoring the health, how healthy is and responsive each core is. So in case that we need a reset, we have some system, and that's the watchdog, which can reset that one core which is, let's say, in trouble or bugged or jammed in some false logic. Also, there is inside that APU section, there is SMMU, system memory management unit, with coherent mesh network, CMN. Also lockstep option within each APU cluster. I'm not sure what this means. We will see later in documentation. ARM trust zone also unknown to me. ARM v8 crypto and neon extensions. Probably some crypto core which is doing encryption for different purposes, maybe especially for the communication and so on. If something needs to be crypted and sent or decrypted and so on. Also, Beside APU, inside the processing system, there is RPU. It's a real-time processors unit. Maybe this is mistake. It's a real-time processor. Yeah, probably there is a multiples of them. Subsystem in the processing system. There is up to 10 ARM Cortex R52 cores organized as clusters with 2 cores per cluster. So again, we have different cores, as we can see. Maybe I should bold this. So 2 cores per cluster, so it means that we have five clusters. Again, ARM Trust Zone, also system watchdog timer for each RPU cluster. So each of these 5 clusters has its own watchdog system, also I/O peripherals, and so on. So I think this is enough for the first video, where we make a short introduction. I think that similar, this A70A and maybe this R52 Cortex cores, especially this one, I think we can find in maybe telephones. They are part of the telephones, but I will check of the telephone chips, and I will check that information, and I will tell you more about that later. But this should be enough for the first video. At least we should start with some kind of, let's say, automotive chip and chip for the different purposes, probably robotics and so on. I made similar video on Serbian about Orange chip, and I will probably make the soon a video about Orange chip but on English. So, and then when I do that, we can do the side-by-side analysis. But what can I tell you for now, for sure, is that this section, which is programmable logic, it's not present, I think, in Orange chip, which for the first, let's say, comparison, this is plus for the AMD Versal architecture and technology. One thing I can say also is that AMD is intensively have collaboration with Xilinx, which is, let's say, master of FPGAs and programmable logic on chip. So we can see from where it is originate. So that's it for this video, and thank you for listening. Have a nice day, and I hope we can hear each other in a brand new video. Bye bye.